Right, Bismillahirrahmanirrahim. Assalamualaikum. Very good morning. So today we're going to continue on the chapter 6 on application and linear angular kinetics. Alright, so for the first slide, it's about the basic concept related to the kinetics. So actually, what is kinetic? Kinetic is concerned with what causes a body to move the way it does. So study of the action of forces. It's about one particular thing that move either our body or either a machine. So it's all about how the way of the things or human being moving to one place to another, right? So basically, kinetics is not just about the moving; it's about an action of forces. So ada gerakan daripada daya yang terlibat. Okay, seterusnya, what is forces? So dalam basic kinetics, kita kena tahu bahawa ada wujudnya force. Force ni adalah daya. Okay, so what is force? Force is a push or a pull characterized by magnitude, direction, and point of application. When we talk about forces, it is important to know that, to remember that the forces including or being characterized by the magnitude, direction, and also point of application. Okay, we have learned about forces in the chapter 3 if I'm not mistaken. So please refer back to the previous chapter, right? So in order to see or to find the value of forces, the measurement will be force equal to MA. Okay, mass times acceleration. Okay, unit is in Newton. Okay, there are two types of forces. There is internal and external forces. So forces that act, the internal forces is the forces that act within the body. Very important to concern about the nature and causes of injury. So internal forces we need to know in order to know the cause of the injury. Where does it come from? If the forces is from the muscles, or other forces. So we have to know whether the forces is affected to the body, which is the muscle and etc. Okay, the external forces is forces that act on an object as result of its interaction with the environment surrounding it. It either contact or non-contact forces. Okay, so external forces adalah bergantung kepada pergerakan sesuatu objek tadi yang disebabkan oleh interaction with environment ataupun surrounding. Contoh, sekiranya bola tu, contoh kita main badminton, awak boleh tengok dekat situ kan, ada some of the lecturers play badminton, so ada bulu tangkis. Bulu tangkis tu menghasilkan forces. Forces tu dihasilkan oleh daripada daya yang berlaku masa kita smash the ball. Okay, siapa yang membawa daya tersebut adalah bulu tangkis. Okay. Bulu tangkis ni interaction towards other opponent is resulted from the environment, our surrounding. Kalau ada angin yang tinggi, so mungkin dia akan result higher forces ataupun lower forces. So that is called as external forces. Right. Force and torque. Sorry, tadi kat mana? Okay. Force. In a Newton law, there are 3 physical laws that describe the relationship between forces acting on the body and its motion due to those forces. Okay, there is kita ada belajar hari tu first class, second class, third class. Okay, dalam Newton law pun ada first law, second law and third law. Okay, so first law, force is represented, the three physical laws that describe the relationship between forces acting on a body and its motion due to those forces. Okay, the first law, force is represented as necessary to start, change or stop motion. Okay, so the first law, either before sesuatu objek ataupun body moving, dia nak start to move, to change the direction ataupun to stop the motion. The second law, force influence the rate of change in the momentum of an object. So the second law of forces, dia dipengaruhi oleh jumlah pertukaran ataupun jumlah changes dalam momentum daripada sesuatu objek. Contoh, bila kita dah start kereta, kita masuk gear, kita nak accelerate. So daripada first gear tukar ke second gear, kita menggunakan second law of forces. So dipengaruhi oleh berapa changes, jumlah changes kepada momentum tersebut. Okay, third law, force is being involved in the action and reaction that cause in the interaction between two objects. So dia ada action and reaction. Okay. Okay, so we're going to go further on the first, second and third law. Alright. Force torque. Okay, kita dah belajar torque masa last chapter yang saya bagi lecture. Okay. Please refer back what is torque. Okay, force torque is force-related characteristic of human movement, involve rotation of the body segment around joint axis. Okay, ingat lagi joint kat mana? Titik axis, joint axis. Kalau elbow dekat mana? Kalau dekat tangan, joint axis kita dekat elbow. Okay, and then the effect of this rotation is called joint torque rotary force. Okay, kalau ada effect daripada rotation tadi, contoh kita buat kita guna shoulder untuk pusingkan kan, kita warm up kan. So rotation tadi disebabkan berlaku around the joint axis, and then dia dipanggil joint torque ataupun rotary forces. It is a measure of the amount of twisting along a certain joint. Okay, contoh macam bila kita nak smash bola, kita mesti rotate, pusing kan. Okay, yang tu yang kita nak tengok, joint ataupun rotary forces. Kita measure amount of twisting along a certain joint. Okay. Okay, seterusnya, how to measure forces? So the first one, we can use direct measurement. The direct measurement, we use force plate. Okay, kalau dekat kita punya lab, kita ada force plate yang kita duduk, kita berdiri dekat atas force plate tu, kita jump higher and then kita boleh kira how much the forces. Okay, and the second is force transducer. Force transducer ni, kita tengok banyak, kita tengok the transducer akan measure berapa banyak forces kita, and the strain gauge. Okay, and then there are also indirect method of measuring forces. That is the second law, which is kita kira forces equal to mass times acceleration. So it assess acceleration from a kinematic analysis of a movement. Okay, kita kira berapa direction, berapa mass, berapa berat dia, berapa laju acceleration. So daripada acceleration tu kita kena kira balik macam mana nak dapatkan acceleration. Okay. Alright. Next is forces. Kita masih lagi dalam topik forces. So what is body free diagram? Okay. Kalau kita tengok kat sini ada satu biji bola. Okay, tengok dekat dalam dalam figures yang dibagi, ada sebiji bola. It is the weight ball. Okay. Air resistance akan mempengaruhi bola tersebut, begitu juga dengan force applied by racket. Okay, ini adalah bola tenis. Okay, and then ball being struck by a racket. Okay, dia dia dipengaruhi oleh record tadilah. Okay, what is free body diagram? The body diagram. Okay, diagram showing vectors representations of all forces acting on a defined system. Okay, this is the body diagram. Okay, bola tu lah sendiri dia tak ada apa-apa. Okay, yang mempengaruhi dia adalah air resistance which is external because of the surrounding, and force applied by the record yang dihasilkan oleh kita punya muscle which is our tangan, joint and muscles. Okay, so force tadi dipengaruhi oleh force tadi mempengaruhi bola dan dipengaruhi oleh udara. Okay. Okay, contoh dekat sini, there are two free body diagram showing the acting forces. Okay, so the first body diagram is the racket and also the ball. Okay, dekat ball ni ada weight, right? Force being applied by the racket to the weight, which is the ball, and the racket is being affected by the air resistance. So force applied by the player, by the muscles and the joint. Okay, and weight is on the racket. Okay, when the racket touch the ball, force being contacted to the ball, and force applied to by the racket to the ball, and the ball will be affected by the air resistance. Okay, there are two free body diagram. Okay, so this is your homework. I would like to see you to do the homework or the tutorial, and you will be discuss the homework in the next class with Sir Shafiq. Okay, the question is illustrate a free body diagram that represent the force acting on a body under the following situation. So nanti keluarkan setiap satu elemen tersebut dan jangan lupa untuk explain briefly. Okay, use symbol in your illustration such as W, Fa, normal forces, Fn, P, drag forces, Fd, and friction forces is Ff. Okay. Alright. So next we're going to look at the centripetal force. The centripetal force is the force directed towards the center of rotation for a body in rotational motion. Okay, so forces tu being applied daripada luar towards the center of the rotation. Contoh, kalau macam kita apa yang rotate dalam badan kita, senang kita punya shoulder lah kan, sebab kita pakai ball and socket. Okay, so forces being directed towards the center of rotation. Contoh bila ada kawan kita yang tolak tangan kita ni directed, so dia akan the force tu akan be directed to the center of rotation. Center of rotation kat mana? Dekat sini lah, kat tengah ni. Okay, for a body in rotation motion. Okay, kita kira FC sama dengan MV. MV kuasa 2 bahagi dengan R, rotation. Okay, M is the mass, V is the velocity. Okay, ataupun kita boleh guna FC sama dengan mass darab rotational and darab dengan tadi apa? W, the force of gravity. Okay. Alright, the centripetal forces, example of that, hammer throw. Okay, bila kita buat hammer throw, when athletes make a hammer follow a circular pathway, they apply a centripetal force by pulling inward the hammer. Kalau kita tengok orang main hammer throw tu, dia kena pusing dulu kan, pusing from the center of the rotation. Okay, so daya ataupun acceleration kita akan tengok daripada center of rotation. Center of rotation adalah dekat bahagian, kalau awak tengok kat sini, dekat bahagian tengah ni. Okay. Kalau kata awak pegang golf club pun, katalah awak pusing golf club tu, yang awak pegang tu, awak punya center of rotation dekat kepala golf club tu. Okay, and then the acceleration will be calculated from the head of the golf club. Okay, in these cases, kita ambil daripada bulatan ni. Bulatan ni adalah the hammer lah kan, bola yang besi tu. And then kita ambil daripada the center of axis towards the forward as the acceleration. Okay. Okay. Next is resistance to angular acceleration. Kita nak tengok berapa banyak resistance kepada ataupun rintangan kepada angular acceleration. Angular ni mestilah dia dalam keadaan circular lah, melengkung. Okay, tapi ada acceleration. Contoh kalau macam kita bawa kereta, kita guna jalan yang roundabout, so akan berlakunya angular acceleration. So dalam defining the resistance to angular acceleration, it involves the movement of inertia. So the movement of inertia is the initial property for rotating bodies represent resistance to angular acceleration. Okay, it is based on both mass and the distance. Mesti ada penglibatan kedua-duanya yang kita kira force equals to mass time acceleration. Okay, dalam angular acceleration ada juga distance dan kita kena based on kedua-duanya, berat dan juga distance. And the mass is distributed from the axis of rotation. Okay, so the quantity expressing a body tendency to resist angular acceleration, and it is the sum of product of the mass of each particles in the body with the square of its distance from axis rotation. Okay, so dalam resistance to angular acceleration, kita tengok dekat sini, this is the axis rotation. Okay, here is the axis rotation. Dekat sini ada mass dan this is the rotation. Kenapa dia ada banyak sangat rotation, ada movement, ada mass, ada resistance and mass, resistance and mass. So movement of inertia is the sum of the product of each particle's mass, m is the mass, and the radius of rotation. Okay, for a particle square, inertia equals to sum of mass times resistance kuasa 2. Okay. You can refer to the study here, effect of bad grip on baseball hitting kinematics, in order to be clear for resistance to angular acceleration. Okay. Alright. Next, radius of gyration. So distance from the radius of gyration is the distance from the axis rotation to a point where the body mass could be concentrated without altering the rotational characteristic. It is used as the index of mass distribution for calculating movement of inertia. Okay, inertia equals to mass times apa dia? Kita kira the rotational characteristic. Okay, so use as the index of mass distribution for calculating movement of inertia. So inertia equals to mass times K2. The K2 is referring to the where the point of axis distribute the mass, the height, produce the mass of the distribution. For example, which we can see in the next figure, the knee angle affected movement of inertia of the swinging leg with respect to the hip because of the changes in the radius of gyration for the lower leg, which is the K2, and the foot is K3. So each of our legs that involved in the movement is divided to segment. So the first segment will be the hip, the second segment will be the gastrocnemius, and the third segment is the foot. Okay, so if we are in a motion of walking, the radius of gradation could be calculated from the hip. The distance is from the hip towards the muscle involvement or segment that involve in producing the acceleration. Okay, alright. Next is angular momentum. Angular momentum is the quantity of angular motion possessed by a body. It's measured as the product of movement of inertia and angular velocity. Okay, and then this is the formula that could be used in order to measure the angular momentum by using the product of movement of inertia and angular velocity. Okay, so the angular momentum is referring as H equals to inertia times force of work. So angular momentum, what we can see here is angular momentum is the sum of local term, okay, inertia, S and work. Okay, and the remote term is MR2, work aggregation. Okay, so this is the center of gravity, whereby and the distance to the center of gravity 2 is directed to the gastrocnemics, and this is the forces of work that will kick the ball. Okay, so this is the gravity. Alright. Next is, tadi kita dah tengok yang ni, kita tengok angular momentum. It is the principle of conservation of angular momentum. The total angular momentum of a given system remains constant in the absence of external torque. Okay, this is what we can okay, sorry. Okay, so now we're going to look at the angular momentum. Principle of conservation of angular momentum. So how do we conserve angular momentum? So the total angular momentum of a given system remain constant in the absence of external torque. Okay, so dalam angular momentum ni, bila berlakunya bila jumlah kepada angular momentum tadi yang diberikan oleh sistem remain constant, tak ada perubahan dekat momentum disebabkan tak ada external force, external torque. Okay, so dalam angular momentum awak boleh tengok daripada diving kan, dia nak buat somersault kan, when the angular momentum is conserved, there is a trade-off between movement of inertia and angular velocity, whereby the top position is the small inertia and large work, and extended this is the extended position, which is the large inertia, the large movement of inertia and small of angular velocity, which is the force of work. Okay, angular velocity. Okay, kalau kata tuck position, dalam keadaan yang dia tuck ni, okay, dia punya inertia, movement of inertia dia akan jadi kecil, but the work of action will be the angular velocity akan increase lah, akan banyak lah. Meanwhile bila dia extended, dia ada high movement of inertia and small number of angular velocity. Okay. So boleh tengok dekat sini apa maksud trade-off, a balance achieved between two desirable but incompatible features of or compromise. Okay, and the conservation of angular momentum. Analyze the conservation of angular momentum that occur during airborne or velocity spike. So waktu orang spike tu akan ada berlakunya perubahan atau conservation of angular momentum bila orang spike bola. Orang nak spike bola kan ada conservation of angular momentum. Dia tak ada, bila dia sentuh bola tu tak ada tak ada external torque, dia akan constant. Okay. Okay, boleh refer kepada chapter 14 dalam textbook, page 457. Okay, wherever gravity is only acting external forces, angular momentum is converse, and the total angular momentum of a given system remain constant in the absence of external torque. And when the angular momentum is conserved, there is a trade-off between movement of inertia and angular velocity. There are two legs, hip and hitting arm, and also shoulder. So the flex position will have small movement of inertia and large momentum. And when extended, it will create large inertia, movement of inertia, and small work of force of momentum. Okay. When we see on angular momentum, it is a changes in angular momentum, which is the angular impulse, the product of torque and the time interval over which the torque acts. Okay. So ini menunjukkan kata bila kita buat ada berlakunya perubahan dalam angular momentum tadi, so akan ada kehadiran akan berlakunya angular impulse. So angular impulse ni disebabkan disebabkan oleh product of torque and the time interval over which the torque acts. Okay. So dalam angular momentum, dalam keadaan tadi kita tengok gimnastik ke, kita tengok divers ke, dia nak buat backward somersault. Okay, dalam atas springboard, reaction forces akan terlibat. Springboard tu akan bagi impact of forces and multiplied by the movement arm from the divers center of gravity. Center of gravity. Okay, which is the diameter will be there. And creates a torque that generates the angular impulse that produce angular momentum at takeoff. Okay. So dalam ni berlakunya CG from the axis, the diameters daripada ni kan. Lepas tu bila dia guna springboard ni akan adanya kehadiran reaction of forces. Dan bila dia somersault ni, dia akan tuck in adalah nanti movement of inertia and also the momentum, angular momentum. Okay. Next, kita tengok angular analogues of linear kinetic quantities. Angular equivalent of linear kinetic quantities. Okay. Dalam linear ada mass, force, momentum, and also impulse. For angular akan ada momentum of inertia, ada torque, penglibatan angular momentum dan juga angular impulse. Okay. Seterusnya, mechanical behavior of bodies in contact. So, the mechanical behaviors of body in contact akan berlakunya impact, which is a collision characterized by the change of a large forces during a small time interval. Okay. For what happened following an impact, this depends on the momentum present in the system and the nature of the impact. Okay, so kalau kita buat apa-apa pergerakan yang laju yang melibatkan the exchange of large force and also the small interval time, macam contoh kita main badminton, kita nak smash, ada berlakunya large forces daripada tangan kita nak jumping kan, tangan kita nak pukul kan dengan laju, and adanya small time interval, time daripada ni sangat pendek. Okay, so berlakulah impact, right? So the nature of impact is described by the coefficient of restitution, a number that serves as an index of elasticity for colliding bodies and is represented as E. Right? So the coefficient of restitution is negative E equals to relative velocity after impact divided by relative velocity before the impact. Okay. And next, the differences in two balls' velocity before impact is proportional to the difference in their velocities after impact. The factors of proportionally is the coefficient of distribution. So, the factors adalah the coefficient distribution, okay, yang akan menyebabkan impact tu berlaku. So, awak tengok kat sini ada dua biji bola, okay, ball velocity before the impact, okay, U1 and U2, and this is the V1, V2. U1, U2 adalah before the impact, first distance ataupun pergerakan pertama. V1, V2 adalah velocity yang kedua, which is the ball velocities after the impact. Okay, so kita nak dapat in order to get the coefficient of restitution, the velocity before and after, before the impact will be the velocity before the impact is equal to the restitution, the ball velocity before the impact. Okay, next step, there are two types of impact. Maafkan saya kalau dia dengar orang menjerit-jerit itu. There are types of impact: perfectly elastic impact and also perfectly plastic impact. Okay, the perfectly elastic impact in which the velocity of the system is conserved, which is the E equals to 1. Okay, don't forget that the E is the representative of the colliding bodies, the elasticity index of colliding bodies. Okay, and then perfectly plastic impact in which there is a total loss of system velocity, which is the colliding bodies equals to 0. Most impact falls in between perfectly elastic and perfectly plastic. Okay, so the closer the coefficient of restitution to the 1 is showing that the more elastic is the impact, and if the closer the coefficient of restitution to the 0, the more plastic is the impact. Okay, so alright, so this is all for today. Any question? If you have any question, you can drop your question to the your class group and ask a question. And don't forget to finish up your homework, your tutorial, in order to sharpen your skills of calculation. Right? That's all for today. Thank you.